Hello, welcome back to our channel, and we have come up with a new problem statement in electronics and telecommunication. As you can see on your screen, we are given this circuit, and this circuit has a current source, two current sources, 1 milliampere each. You have got 2 volts of voltage source, and there are like 4 resistance, 2K and 1K and 200 ohm. And now let us read the problem statement. It says that in the circuit shown below, the current I flowing through the 200 ohm resistor is, this is what we have to find out. Okay. So we are basically asked to calculate this current value, which is flowing through the 200 ohm resistance. So how to solve this and approach this problem? So what I would do, I would redraw the circuit using the source transformation technique, which says that I can replace this voltage source in series with the resistor by means of a current source across the resistance equivalent of this combination. Similarly, I can represent this current source across which a 1K is connected, and its equivalent would be a voltage source in series with a resistor. So that's a dual kind of source transformation. So what we'll do here, let me just draw the or redraw the circuit to in order to solve this. So this circuit will get such transformation. We will draw the 2 volts voltage source as it is, and then we have this 2 kilo ohm resistance as it is. Now we have this 2 kilo ohm resistance as it is, and we have got this 1 milliampere current source as it is. We'll keep it like that. And here is how our circuit is getting completed. But now with 1 milliampere across 1K would be represented or can be represented as, let us have this 1K as it is, and there'll be a equivalent voltage source of 1 volt in series with that. So voltage will be I times R. So 1 milliampere multiplied by 1K will be the 1 volt. Okay, and the resistance is there. Similarly, if you take the dual of it, so I would be V over R. So 1 volt divided by 1K will be a 1 milliampere current, as we can see here. And then you have this 200 ohm resistance as it is. So this is your 200 ohm resistance, and this is the current actually we want to find out. So this is kind of, we'll say that source transformation method. Okay. So how we go further, we will do simply the nodal analysis for this network, in which we apply, let us say this node, we call it as a VA or XYZ, whatever. And then at this node, we will apply the KCL, apply the KCL, Kirchhoff's current law, which says that VA minus 2 volts. So this is the current that is we are talking about, divided by 2 kilo ohm plus VA divided by 2 kilo ohm. So that's the current, that is VA divided by 2 kilo ohm again, plus VA minus VA plus, actually, because there is a negative sign here, plus 1 divided by what you can say here, 1.2K. Okay, so 1K and 200 ohms. So that is a series combination of the resistance is equal to this current right here. Just a second. Right, so it is equal to this 1 milliampere current source. Okay, so you can see now we have completed the nodal analysis applying to this circuit. Now from this, you can go on simplifying this. So it would be like VA minus 2 plus VA divided by 2K plus VA plus 1 divided by 1.2K is equal to 1 milliampere. Okay, and from this, you have to solve this further, which will give you the value of, let's say, VA would be about I have calculated, it comes out to be 0.636 volts. Okay, so just you can also calculate this and write the value of VA. Once you obtain the value of VA, it is this current, which is the value of simply VA plus 1 divided by 1.2 kilo ohm. Again, 200 ohm and 1 kilo ohm, they are in series. So this network is like you have VA here, and you have like 1.2K, and then you have like this voltage source of 1 volt. Okay, and that's the circuit you have, and that's the current you want to calculate. So this is the value. So since you know the VA, which is 0.636 plus 1 divided by 1.2K, so it comes out to be 1.636 divided by 1.2 kilo ohm. So approximately, if you see, the value comes out to be 1.36 milliampere. Okay, so that's the value of the current you will have. Okay, so now I ask you to do it as an exercise. Instead of having this kind of transformation, I ask you to transform this voltage source in series with a resistance with its equivalent about I would be about volt divided by resistance. So it is 2 volt divided by 2K, again 1 milliampere in parallel across with the 2 kilo ohm resistance. Okay, transform that and then solve, and you will see that. Let me know in the comment whether the value of current is the same. So hope you found this video useful, and if you did so, share it with others. Stay tuned for more engaging contents like this, and wish you happy learning.